In this section, we'll analyze collision of bodies of different materials. Let's discuss when two bodies collide, what will happen if their material changes. As we have discussed that two bodies of masses say m2 and m1 moving at a speeds u1 and u2, with u1 more than u2 are moving along same line of motion. In this situation, if u1 is more than u2, obviously the first ball is going to hit the second ball at some state, where we can state as the speed of first ball is more than that of the second ball. In this situation, the first ball is going to deform the second ball at the point of contact. So next situation would be like this. Due to deformation between the bodies, the situation would be like this. I have drawn the figure slightly enlarged. This is the first body of mass m1, this is second of mass m2, and in between they are having some deformation. Now the deformation will continue until the speed of the two balls will be equal. So we can state if bodies are elastic, the potential energy in the bodies is continuously increasing. So at the time when the speed becomes equal, the deformation will be maximum, and we can state this as the potential energy maximum state, and kinetic energy of the system is a minimum state, which we already studied. Now in this situation, if bodies are elastic, the bodies will experience a restoring force in opposite direction. This we can denote as Fr, due to which the speed of the second ball will increase because restoring force is acting in the same direction. For the first body, restoring force is opposite to the speed, so it will decrease. Further, we can say that the balls will separate due to restoring force. This m2, this m1, they will be moving with the speed v1 and v2. So if bodies are elastic or even if partially elastic, some restoring force will exist in the system and bodies will certainly separate. So we can say for elastic or partially elastic material, bodies will separate. But see what will happen if the material of the two balls is perfectly inelastic. We have just now studied that in case of inelastic material, no restoring force exists in nature. That means if no restoring force, the speed won't change and the bodies will remain in deformed state. So we can state the final situation would be this, in which the two ball in the maximum deformed state will move as a single body, or the two balls will move together. Both m1 and m2 will move with the speed u. And this speed u can directly be calculated as momentum of system remains conserved. So here we can write m1 u1 plus m2 u2, which was the initial momentum. Finally, if the material is perfectly inelastic, no restoring force will exist and bodies will not separate, they will move together with the speed u. So we can write the final momentum to be m1 plus m2 into u. Here we can write u is equals to m1 u1 plus m2 u2 upon m1 plus m2. This is the final speed of the two balls with which the two balls are moving together. Another important thing which you can see from this expression is this: the velocity of center of mass of the two balls before collision. And we can say, as no external forces acting on this system, center of mass velocity will never change. So at every instant of time, center of mass will carry on moving with the same speed, which we can verify that after collision also the two balls are moving with the same speed as that of their center of mass, because now center of mass will be lying exactly midway between the two balls, or not midway. I'm just taking these two balls as point masses, so we can consider the center of mass will lie on the two mass system only. So that will move with the same speed u. So in case of inelastic material, along line of motion, bodies do not separate. So you need to be careful about this statement also. That is going to be the basis of many different kind of problems in future.